All right, so now we're ready for Johannes Kepler's third law of planetary motion. And the first law was that a planet goes around a star in an ellipse. His second one was that a planet will sweep out equal areas in equal amounts of time. And now we're ready for his third one. So the third one is going to relate the amount of time it takes a planet to make one complete orbit. That's going to be called the period. So the period is going to be given by one of these things. So that's capital T in Greek. So that's a tau. So this thing is the period. It's the time it takes to make one complete orbit. Do you remember when we did pendulums? And with a pendulum, we had the period of a pendulum was the time it took to swing all the way over and then to come back. And then we used the same letter to represent that. So this is the period of a planet, the time it takes to make one complete orbit. So he found that there was a relationship between the time it would take to orbit and how far away it was from the star. So he, now the actual formula is the distance is the semi-major axis, so that we had a picture of an ellipse, and then this was the major axis. And so therefore the semi-major axis is going to be this distance right here. But we said that for most planets it's going to be a circle. It's going to look like a circle. So instead of using the semi-major axis for the r in that formula, we're just going to say it's the radius. So the radius of the orbit is going to be the r. So our formula is going to be the period squared is going to be equal to r cubed. Now, remember this is back in the 1600s, so Johannes Kepler didn't have the metric system. And so he basically invented his own units. So he decided that the unit for distance was going to be the astronomical unit, the AU. So an AU is going to be the distance from the Earth to the Sun. That's going to be one astronomical unit, the distance from the Earth to the Sun. And then he decided that for this one over here, he designed the equation so that this would be in Earth years. Okay, so let's try it. If the distance to the Sun is how many astronomical units? 1. So what's 1 cubed? It would be 1, okay? And now to get rid of the square, we need to do the square root. So what's the square root of 1? 1. So how long does it take the Earth to go around the Sun? 1 year. So this formula works for the Earth. But the good thing is we can use this formula for basically any planet in our solar system. Okay, now that's as far as we need to go with this, is be able to use this formula. But I wanted you to know that this formula is incomplete. So when Sir Isaac Newton came on the scene, he also showed that it would depend on mass. So that what we need to do is to divide this thing by mass. And then this m would be the mass of the star plus the mass of the planet. And then that goes into this formula as well. And so if we want to keep this thing dimensionless, then the unit that would go into this formula would be solar mass units. And so the mass of the Sun in solar mass units is 1. And so we would just plug in a 1 for this m. Now, if we want to take this formula and make it metric, so that we would plug in seconds for the period, and then meters for the distance, and then kilograms for the m, then that's the formula that we would use. So the Newton's version of the formula, and you can see it's got that big G thing in there. We're not going to use it. So we're just going to be using Kepler's original version of his third law. All right, so here is an example. A planet is located 7 astronomical units from a star. What is the period of that planet? So we know the distance. We know that the distance r is equal to 7 AU, and we're trying to solve for the period. So we write down our formula, period squared, distance cubed, and again, we're doing the original form of Kepler's laws, so let's not worry about the m thing on there. And then plug in our numbers, and now be very careful that you put the 7 where you're supposed to. This is time, so remember T for time, whereas this is distance, so you need to put the 7 over here. So 7 cubed is 343, and so I have students that say, yep, that's the answer, 343 years. Okay, but what did they forget to do? You got to get rid of the squared by doing the square root. So square root of 343 is 19, and then the unit is in years. So it would be 19 years. Okay, let's take a break. When we come back, we will talk about other kinds of orbits that a rocket ship could have.